Number 39, sketch the graph of the rational function, and we've been given f of x equals x minus 2 over x minus 3. All right, so let's go ahead and first and foremost, let's see if we can find our vertical and horizontal asymptotes. And for the vertical asymptote, we know all we're going to do, take the denominator, in this case, x plus 3, and set it equal to 0, and then solve for x. So not too bad here. All we're going to do, we'll subtract 3 on both sides, and that'll give us x equals negative 3. All right, so let's go ahead and I'm going to write this in red so that when we graph it, we know what we're dealing with. So x equals negative 3. So negative 1, negative 2, negative 3. This is our vertical asymptote. All right. So there's our vertical asymptote. Now let's find our horizontal asymptote. And how about we use, green? Well, the horizontal asymptote in this case is relatively easy. We know, based on what we looked at a couple questions ago, that the horizontal asymptote is found using, in this case, a combination of the numerator and denominator, because what's the highest degree upstairs? Well, that's a 1. What's the highest degree downstairs? Well, again, that's a 1. And we know when the degrees of the numerator and denominator match, we have to take a ratio of the coefficients of those, the largest terms, or rather the largest powers there. And so, in this case, we'll have y equals 1 over 1. Well, 1 over 1 reduces to just 1. So in this case, y equals 1 is our horizontal asymptote. All right, so y equals 1. And we'll go ahead and draw that. All right. Now what we're going to do is I went ahead and made two xy tables here. And notice I labeled this one left of the vertical asymptote, right of the vertical asymptote. And all that refers to is I like to choose several values of x that are to the left of the vertical asymptote and several values of x to the right of the vertical asymptote to help me graph. So in this case, if our vertical asymptote is at x equals negative 3, well then a couple values to the left, meaning smaller than negative 3, well, we could do negative 4, negative 6, and how about negative 8? And I literally am choosing these arbitrarily. You could choose negative 5, negative 7, negative 9. They're really up to you. And then some x values to the right. Again, I skipped by 2's here. So how about we look at negative 2, 0, and 2. All right, so let's go ahead and just for the sake of time, I'm going to use the calculator to help us find all of these. And to do that, go from your main screen here, y equals, and we're going to input this function. All right, because what we're going to do is we're going to use the table feature of the calculator to help us evaluate. All right, we're going to enter the function, so x minus 2 divided by x plus 3. All right, and what we can do is use the table. So we're going to hit the second button and then table. But actually, really before that, go ahead and hit the second button and then table set. Because what you want to do is you want to make sure that your calculator, the independent variable, is set to ask. So we'll go ahead and set it to ask, and then you can go ahead and hit the second button and then table. And now what this allows us to do is manually enter x values, and the calculator will calculate the y value. So in this case, if we say negative 4, we get positive 6. If we enter negative 6, we get 2 2/3, and what else? Negative 8, we get positive 2. All right, so let me go ahead and write those in. So 6, 2 2/3, and positive 2. All right, let's go ahead and figure out what these corresponding y values are. So we have, oops, moving the screen a little bit. There we go. All right, so negative 2 is negative 4, corresponding y, and when x is 0, we get negative 2/3, and when x is 2, we get 0. All right, so let's go ahead and put those in. So we get negative 4, negative 2/3, and 0. All right, now we're ready to go ahead and plot all of these and see what our graph looks like. So negative 4, comma 6. So negative 4, comma 6. There's 1, 2, 3, 4, 5, 6. All right, so there's that one. Negative 6, and then 2/3. So negative 4, negative 5, negative 6, and 2/3. 1, 2, and somewhere around there. All right, and lastly, negative 8, negative 2. Well, there's negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and then positive 2, somewhere about there. And we can see based on those 3 points what our graph appears to be doing to the left of that vertical asymptote. And then let's go ahead and plot these 3 points here. So negative 2, negative 4, 1, 2, 3, negative 4, 0, and 2/3, negative 2/3, about there, and finally 2, 0, about there. So we can see based on those 3 points, and I went over the asymptote. Remember, our graph is going to come infinitely close to these horizontal and vertical asymptotes, but never quite touch the asymptotes, right? And so there's number 39. Looks something similar to that. And let's go ahead and just look at the graph. I don't think we did that yet, just to see what happens. And there we have it. Looks pretty close to me. So there's number 39, our graph.